face higher stress level and more mental health issues than ever before. In this fast-paced world, people are getting exposed to more stressors like financial issue or work challenges. Second is the self-assessment and manual data collection of indicator not be reliable. This is because in order to assess one's mental health condition, the real-time tracking of data and indicators such as heart rate is very important. Self-assessment might cause bias and therefore cannot fully reflect the real condition of one's mental health. Last but not least is the distance assessment of a patient's health by medical personnel can be a challenge due to traveling and scheduling issues. Patients living in rural or isolated areas might find it difficult to schedule an appointment and getting treatment from the medical personnel, and therefore through testing their treatment and causing their mental health condition to become worse. The objective of our project is to develop a monitoring system utilizing AWS that can predict one's stress level based on the data collected from the smartwatch and to alert the user and provide suggestions on how to improve their current mental health when stress level is too high. That's all from me. Thank you.
Hi everyone, my name is Deng Shi. Now I will present about the architecture diagram of the proposed solution. So the first one is the smartwatch. The smartwatch is used to collect the data from the user such as oxygen level, heart rate variability, and so on. Then the data will send to the IoT core. So the IoT core will collect the data and so that other service can use the data for further process. So the first one is about the SNS. So the SNS will send the help data to target user. So in this case, the target user is smartwatch user and healthcare personnel. So that smartwatch user can know more details on their data, and the healthcare personnel can from the data they can know how to track the person, how to track the patient. So besides, you also will send a notification when the user level when the oxygen level of the user is less than 19. So the result will display on next page. So after this is about the imagine kinetic data stream. So this one is to collect the stress data from IoT core to achieve the real-time process for the stress data. So then the lambda is used to convert the data so so that it can compatible with the Amazon S3 so that it can be stored in a database data in a database. So then it's about the SageMaker. SageMaker is used is has inside it is a pre-trained model to predict the stress level of the user, and the Amazon Lambda is used to send the data from S3 to SageMaker. At the same time, it can perform some prediction on the data. Then finally the data will send back to the S3 to store it. So then Amazon so then business user and government can analyze the data by access the Amazon quick site so that they can get more insight on the data. And finally, the Amazon Lambda will also perform some calculation and send the result to the user. So here is the output of the system. So this output display the stress level count of stress level per day. So we can see that the one is mean that facing in healthy state, and the four mean the person facing the several stress level. So this one, the first diagram is show the stress level notification. So when a user is facing high stress level, so the quick site will send the notification send to let the user know he is in high stress level state, and they also will give some recommendation to solve how to tackle with the problem. And when the oxygen level is too low, such which is lower than 19, it will send out a notification as well. That's all for my part. Thank you.
Good day, I'm Ho Chumai. So today I'm going to present the comparison between the proposed smartwatch and Samsung smartwatch. They both have similarities and differences. For the stress monitoring feature, both smartwatches they utilize heart rate monitoring and heart rate variability for stress detection. Then for stress tracking insight, the proposed smartwatch will send notification about the current stress level and offer the suggestion to reduce the stress level. But the Samsung smartwatch, they will only provide weekly stress score graph. For reduced stress feature, proposed smartwatch will provide suggestion to reduce the stress level. But the Samsung smartwatch, they will offer breathing exercises guided by on-screen animation. Then for the integration with other apps features, proposed smartwatch does not offer any partnership, while Samsung smartwatch, they partner with Calm for meditation sessions. For data storing and accessibility, data stored locally on the proposed smartwatch, while stress data stored in cloud, accessible via dashboard illustrating daily and weekly stress level for Samsung smartwatch. Then data utilization feature for proposed smartwatch is it has limited utilization of data for stress management, while the Samsung smartwatch have the data can be leveraged by hospital, government, and business for insight and action. Next. Then for the future work, we can implement the machine learning techniques such as CNN, convolutional neural networks to improve the stress level. Then we can incorporate sensors like ECG, electrocardiogram for the heart, and so on examples for more comprehensive stress detection. The third one, we can develop mechanism to offer real-time insights for stress management. And last but not least, the users will be able to track changes in stress level, anticipate period of heightened stress, and take proactive means to eliminate the stress.
Hello, good day. My name is Shichi and now I will be showing you the demo of our project. First of all, our project makes use of the IoT core, and what we have to do is to configure the IoT core, which is to create things and register our IoT device with IoT core. Then we will have to test connectivity between the device and IoT core. So this is the program generating the data for the sensor. You can pass in user ID and the state, and the state represents the current state of the user. For example, if the user is exercising or sleeping and so on. So the program here will generate the user states in random and pass the user ID and state into the function to generate mock sensor data. And after we run the program, we can see that the program has successfully sent the data from the IoT device to the IoT core. And we have various attributes such as user ID, date time, heart rate, and temperature, and so on. Next, we have also configured the SNS service, where we have to create a new topic, subscribe to the topic, and also configure the message routing to send the data from the IoT core to SNS, in which we have to create a new rule for it. So after doing all the configuration and we have successfully subscribed to the topic, if there is a piece of data which has a blood oxygen level lower than 90, an email will be sent alerting the user that there is a very low oxygen level. Next, we have also configured the Amazon data firehose, where we send the data from IoT core to Amazon firehose, in which we will also have to create a new rule for it. And we also created a new Lambda function for data transformation, as well as creating a new bucket in S3 for data storage. So this is the Lambda function that we use in data firehose, which it will convert the data in JSON to CSV format for storage in S3. We have also configured the Amazon SageMaker, where in this case we created a new notebook instance, we trained the model, and we deploy the model. By doing so, we will create an endpoint for it, and we will send data to the endpoint for inference. And to this end, we will create a new Lambda function called send data for inference, and we will also create a new Lambda function alert on stress level, which will check on the stress level after the inference and alert the user if the stress level is very high. So this is an example snapshot of the model training. So as we mentioned earlier, if after the prediction is made on the stress level and we find out that the stress level is too high, a lambda function will be activated and an email will be sent to the user. Last but not least, we have the Amazon QuickSight, and for the QuickSight, we will create a database from S3 and also create visualization from data. So we will create a database from a S3 bucket, and in this S3 bucket, it will store the stress data that is collected before and make inference on the stress data. And after creating this database, the QuickSight can create a visualization, create a graph from the data. And in this case, we have created a graph that shows the stress level of the user in a day. And that's all for my presentation. Thank you.